Hey guys, my team and I at Group Gold will be presenting our solution to Assignment 2, where we created an online bookstore where users can search for items, purchase them if they log in as a buyer, or conversely sell items of their own choosing. These items, which initially populated our database, are from an extensive computer science bibliography, DBLP, which contains around 3 million publications. There are a variety of types including articles, journals, books, proceedings, and theses. Our bookstore has taken an extremely small subset, enough to adequately demonstrate our web application to you. This web application was created using Eclipse, one of the most popular and powerful integrated development environments. Eclipse allows integration of our dynamic web project with Apache Tomcat, our default server, MySQL database, which includes installing a server at the local host, and Hibernate for mapping and querying our database. The structure of our bookstore project was deciding on which design pattern to use. Our group has decided to use a service locator pattern to reduce the amount of connections within the program known as decoupling. A good example to explain why this is necessary is to consider audio within a computer game. Every action, interaction within or outside the game uses some sort of audio, music, sound effects, clicking buttons, etc. It means that in every part of the game, a direct reference or instance of the audio class is required. Changes are difficult to implement since every reference needs to be changed also. Therefore, we can consider a service pattern like a phone book, where different entities can consult the phone book to get a reference to the class they want, a more robust method for web applications. Since our bookstore relies heavily on accessing the database and storing data, this service locator design pattern fits nicely. Different command classes can access this bookstore service to get an instance of the data access objects, DAOs, to retrieve, update, insert, or delete data to the database. A more complex description of this service locator pattern can be found on the course website and using Google. So in this section, I'll discuss what database we used, why it's powerful, and the tools we use to generate the queries, called Hibernate. The database allows the data to become persistent in the fact that items within a user's shopping cart or items to be sold will be the same, regardless of the time, day, week, month, year, not including influence from the admin who can remove items. As an important consideration when creating the database structure is to reduce the amount of redundant information, which we attempted to achieve by having 4 different tables, each having a primary or foreign key. The user information is contained within the user table, linking to the user bean. The publication items within the book item table is linked to the book item bean. The cart table, which links a user with the item, which represents a user having these items within their shopping cart, is linked to the cart bean. And the purchase table, which records user activity for the items they add to the shopping cart, links to the purchase bean. By using this structure, it would save space compared to using a single table, since a lower percentage of all cells which contain an empty or null value will result. We chose a popular database, MySQL, in which there are lots of samples, help, documentation on their website, in setting up our server at the local host, and executing and setting up our database. The other aspect to connect the business layer with this data layer is Hibernate, an open source Java persistent framework project. We use the Object Relational Mapping ORM tool to enable us to create persistent bean classes. So we set up a situation where our bean classes, user bean, cart bean, purchase bean, book item bean, basically acts as the tables. Hibernate queries are much simpler than writing out the full query to access and alter the data, especially when having to join multiple tables together, since the full query is generated at one time. For example, take the situation where we need to insert a tuple within the user table. All we need to do is create an instance of the user bean, start the transaction, save it, and commit. The following query is generated from a single line of code. I'll display the homepage of the Bookstore now so you can actually view the interface. We used a lot of Bootstrap, a powerful front-end framework which includes HTML, CSS, and JavaScript. This allowed us to create the navigation bar, layout, buttons, theme, and the overall presentation of the Bookstore. You'll find most well-presented websites will use Bootstrap. The simple search is contained within the navigation bar at the top of the page, where one can search for items within the database based on the title, author, year, or any detail. Say you want to search for items with the year 2010. I just navigate to the year in the drop-down menu and hit search. The table is part of jQuery plugin, Data Tables, which allows the user to customize the results to order columns, either ascending or descending, displaying a different number of items per page, and changing what page you are currently looking at. The only downside is low performance, since there will be a delay to converting the unformatted table into this elegant and sophisticated structure, especially when trying to display a larger list. Try to notice the delay throughout this walkthrough. In order to use this plugin, all you need to do is link the required CSS and JavaScript files from the internet and initialize the table with a specific ID in JavaScript, either within the JSP itself or in a separate file. As the main point of using the framework was to separate the layers of the project and to reduce coupling, we went with the latter approach. Now going back to the home page, just clicking on the welcome at the top left of the page. This page shows 10 random items using the same jQuery plugin, but setting the paging and ordering to false. More information can be found at datatables.net. Now to the advanced search, which enables the user to search for more specific items or a broad range by using any or all of the fields. For instance, I want to find theses published in 2005 containing the letter Z in the title, and it comes back with 6 entries. Using any of the fields option, meaning I want items which are theses or contains the letter Z in the title or published in 2005, we get 323 entries. So success, it's working. Now the interface is out of the way, let's focus on the code. The simple search form is built into the navigation bar using a get method to send data to maintain the consistency and ease of access for the user. However, unlike the simple search, the advanced search form uses a post method, since get has a character limit of 2000 characters and you can't send null request parameters this way. So say if you leave the book title as null, you can't send this via get, otherwise you get an error. The server executes the corresponding command, where the hibernate query returns a list of book item beans, which is set as a session attribute, allowing the list to be accessed by the results JSP page and displayed to the user. In order to simplify this backend code and the query, only one type of logic was used, either AND or, to combine all the fields together. Just imagine if one was able to select whether the title and author should be combined with and then linked with year through OR. One would have to know the order in which the users use the various logic. It would be possible, but a nightmare to properly code without errors. The login page might seem simple, but there are many situations that must be accommodated for. Successful and unsuccessful verification and login, and various errors, etc. The registration page contains a simple form with an extensive form validation to make sure the user has inputted the necessary and correct information. Most of the form validation stems from HTML5, the new markup which is available for most of the common browsers, i.e. Firefox, Chrome, and the new Microsoft Edge that comes with Windows 10. By adding parameters, patterns, different input types like emails, dates to the JSP form elements, form validation with HTML5 is automatically activated in those browsers that are compatible. In addition, you should notice the variation in colors around the text entries. Red and green indicates that invalid and valid entries respectively. Even though some fields are empty, they are classed as valid since there is no required attribute assigned to these input types. This is why input types with an asterisk next to the names are invalid when empty, since these fields need to have some data inputted. Furthermore, some hints are shown when you click inside of text entry to guide the user in filling out the form correctly. Most of these fields have attached patterns. I'll go to the JSP now to look at the postcode pattern, which reads, it must have 4 valid integers, with each integer taking a value between 0 and 9. More complex patterns, like the one governing the password, can be applied, in which an uppercase and lowercase letter plus a number in any order needs to be inputted. On submitting the form, the register command function is executed, which generates a user bean and saves it within the database. It's important to note the primary key is the username, which is why an error message shows to the user if the username already exists. By attaching a parameter value pair in the form of error true for this instance, we can apply a CWhen choice tag to display a message if this request parameter exists. This is a simple but highly effective method to communicate with the user of an error or problem. This, along with modal dialogues using AJAX, are the only notification methods used within the project. So for instance, for the search bar, at the top of the page, if you click search without inputting an entry, it uses AJAX to show a modal dialogue to say this entry needs to have something in it. A few important things to notice when creating the user bean. 1. The token is generated randomly from a number between 0 and 1000 at one time. And 2. The verify boolean, as well as band, is initially set to false, which means you need to actually verify your account before you can log in for the first time. We've now successfully registered as a new user with the username S1, password capital T, L1, and our email address. So we'll just go to our email utility function where we actually send an email. So first we need to set up where we're actually sending it from. So we've created an email address on this server mail.com, which has less security than something like Gmail. So we can actually send emails without errors. So by setting up this account, we just set like a general password, gold, which is easy to remember. So in our send verify email, we set up a my message, which allows us to send properties, set from, the to address, the set recipient, subject, sent date, and the body. So we say, hello, thanks for registering. Click on this following link, which includes a token that was generated at runtime. And then for our username, we encode it in base64, so a person looking at your email and looking at the link won't be able to know your username, so it's like added security. And then we just send the message away. Now I'll go to the verify user, which shows when you actually click on the link, it gets the token and the username from the request parameter, and then calls the verify user. And we'll just go to the verify function. So find it here. We initially set a boolean to actually determine whether the verification has been successful or not. We basically set up a query where we select the token where the username equals the username, so we actually find out if the username exists, and the token matches the request parameter we saw earlier. If it does, and it hasn't been verified first, so the user doesn't click on the link the second time, it basically updates the verify to true and returns with the boolean equal to true. And so this basically returns a true result. So if we go back to our verify user command, we'll see that if it's true, if it returns true, then it redirects to verify next step.jsp with your username equal to username. So you can actually see what username you actually signed up as if you actually forget to verify. So if we go to the JSP, on this page, it's quite simple. It's just got a single form with a simple input type password. So you can insert your password. You know what your username is because it's already a request parameter, so we set it as hidden. And then this goes to controller servlet with the command login, and if your details are correct, it logs you in. So now I'll just quickly demonstrate this. First, I'll try to log in before verification and see what happens. An error message pops up, which is exactly what we want to happen. I'll go to the new tab, paste the verify link. I'm using a link because I don't want to share my email. It transfers to this verify next step page where all you need to do is type in your correct password, and if your username and password is correct, it logs you in. So I've signed up as a buyer. So this is the welcome page for the buyer. This is the welcome page for the buyer, where the user can purchase items from the website only if they have a valid credit card. In addition to the 10 random items, the welcome page contains some important statistics, including the number of items purchased from the bookstore, the total cost of these items, the total price, and a list of items that have been purchased in the past, so it's like a history. As this is a new account, these statistics are empty, but will change as we'll progress through this walkthrough together. The other major change is in the navigation bar, where the sign up and login links have been changed to a shopping cart and settings icon. Both are drop down menus with a style generated in CSS unique for this bookstore, so we created the CSS ourselves. The shopping cart in theory is similar to most of the websites where you can purchase items from, for example Amazon, where it acts as a temporary location to keep all your shopping items together before you purchase or remove them from the shopping cart. Each item within the shopping cart is inserted into the database using the cart bean, which consists of two fields, username and item ID. As I have been giving an overview to the shopping cart, I have searched for random items and added them to the shopping cart by a button by clicking on a button on the item's detail page. You should notice the number next to the shopping cart icon change as more items are added. In selecting the drop-down menu, only the first 3 items within the shopping cart are displayed, with each a link to its own detailed page. Even though the button to add to the shopping cart still appears, the system won't let you add to the cart again. In much the same way as displaying the errors on the login page, a message tells the user that this current item already exists in the shopping cart, so it doesn't add it again. I'll go over to the shopping cart now, by the drop down menu in the shopping cart icon, and see all items. The table consists of the items within the shopping cart and a checkbox next to each item. Clicking the checkbox means you want to process the item to either remove from the cart or to actually purchase. I'm feeling generous, so I'll just purchase all the items. When successful, these items are removed from the cart table and displayed on the welcome page, which acts as a kind of history. However, for our account, we haven't inputted a credit card number, so we can't actually purchase items. So I'll just go to Settings, Update Details. I'll go down to Credit Card, type in a 13 to 16 digit number, and then proceed to the shopping cart again, clicking all the checkboxes, hitting Purchase, and it shows I purchased all these items. Going back to the welcome page, now you can see the history of it. The other feature I'll briefly mention is the settings drop-down menu, which contains a link to your account details, the ability to change your details, apart from your username, which must remain fixed because you use it to log in. When logging out, the session is removed, which clears out all the data. Starting from the items detail page, where we add a button only when the user is a buyer. So the seller can't access this button, which is what we want. This links to the command servlet with a command that executes the add to shopping cart function. The only request parameter is required is the item ID, since this is the primary key for the book item bean, to uniquely identify the item. If this is successful, the cart is updated for the user who is logged in. It is retrieved and saved within a session attribute with the name cart. The purchase bean, a more permanent version of the cart, is also updated, with the time removed being set as null, since the user has not removed nor purchased the item within the shopping cart. As mentioned earlier, this table is primarily for the admin to keep track of what items are removed and purchased by each user within the Bookstore system. Again, a dummy request parameter is set as part of the redirect link so that a see when tag can identify which message to the user to display. Most important of which is that a user cannot purchase the item they want without a valid credit card. Within the cart JSP page, a list of items belonging to the user is displayed, each with checkboxes next to it, initially unticked. One of the neat reasons to use checkboxes is that as each one is ticked, so that an array of checkboxes, the same request parameter name can be retrieved, allowing the backend code to know which entry has been selected. Then it's just a matter of programming the remove and purchase buttons by adding links to them and making them look like buttons, each having their own command. Showing the remove command now, it's a simple function which removes the item from the cart bean and updates the purchase bean to say that this item has been removed at a specific time. With the purchase command, an email is sent to the seller indicating that their item has been sold. As the primary framework for the email has already been established, remember that the verification email occurred. It is relatively straightforward to implement. One of the main issues with this, however, is that for each item being purchased, an email is sent to the seller, not collectively. So if you purchase 5 items with 5 different sellers or the same seller, 5 different emails will be sent. This will overload the mail server, and the port used to send messages through will be blocked as a result. Hence, this will dramatically impact performance, especially for a large number of users. I'll just navigate to the implementation of the cart now and the purchase beans to get a feel for what Hibernate queries we use throughout the purchasing and removing process. For the cart bean, there are only 2 functions, one to add to the cart and one to remove from the cart. The former just means saving the cart bean within the transaction and committing it. This shows the beauty of Hibernate, where it generates the full queries at one time, so we don't have to. The purchase bean DAO implementation is much the same, with additional function to 1. Record how much money the user has spent on X items within the bookstore, and 2. Return a list of tuples belonging to a particular user where they have actually purchased items, and 3. Retrieve all the items they have added to the cart, regardless of whether they have been removed or purchased, and this is mainly to track user activity for the admin. I'll now log in as a seller. When we initially inserted the 1,000 plus publications into the database from the DBLP website, we used either seller 1 or seller 2 as fake sellers. For each item, the seller was chosen at random due to a magnitude of a random number between 0 and 1. So that if this random number was less than 0.5, then we use seller 1, else seller 2. Therefore, in a particular random situation, half the items will be sold by seller 1 and the other half will be sold by seller 2. So therefore, I've logged in as seller 1, and it should have about 500 items, which is true. Apart from the different statistics, the seller's welcome page is pretty much the same as the buyer. We did this to remove the high workload of generating a different style and theme associated with just the seller, and to maintain the fluidity and consistency of the web application. As being the seller, I have the capability of seeing what items are put up for sale. Under the drop-down menu, go to My Items, or adding a new item to the list to be viewed by every other person coming to the bookstore, whether they log in or not. The My Items page is set up basically the same way as the search results page. So again, we're using the jQuery plugin data tables. However, to each item, we have added a pause and remove button. I'm not going to go over the remove button since this works in the same way as the buyer function. If you need more information on this, please see the buyer part of this walkthrough. The pause button essentially temporarily deletes the item, so nobody can view the currently paused item. This is not to say that only one of the items can be paused at one time, but multiple items at the same time. We use Ajax in this case to send our request to the controller servlet to change the field within the book item table to say we have paused this item. I'll just explain this in more detail. So starting with the My Item JSP, we've got the pause button with a class name of pause item button. When we go to our JavaScript, we can see that as we click this button, it sends a request to the server with a command pause item. This initiates this pause item command where it calls this function here. And if we actually go to this function, we can see it gets the item, it stores it in a book item of type book item bean, it gets the pause and sets it to its opposite, and then saves it back to the database and commits it. So when we come back to our pause command, if this happens correctly, we set a JSON object of success equal to true. If we come back to a JavaScript, if data success is true and the button is of name pause, then we set it to unpause, and vice versa. The neat thing about this approach is that we don't have to reload the page, which can be annoying and frustrating for the user. It would to me. The add a new item also has an Ajax request to get the image link automatically, so the user doesn't have to search for images on the internet. Let's just fill out this form quickly. Let's just say I've written a book and I want a picture. So I click on get a picture link. It comes up with a modal dialog. I just type in what I want to search for, and it retrieves the first image link for me. More information on Google's custom search API can be found here. You should be warned, however, you need to create a Google search engine, get its particular ID, request a JSON object from the corresponding URL link, which includes your Google Developer User ID, search engine ID, and the search name that you're searching for, and then process the JSON object to get the first link. But I'll leave that fun to you. Since the administrator is such an important account, especially for a popular web application, a separate login page has been created. This can be accessed by either manually typing in the location of the JSP page, or typing in the name of the controller server, which has a separate URL mapping just for the admin. The welcome page for the admin is basically a no-frills look compared to the buyer and seller pages. It contains similar functionality, including looking at your details, updating them, and logging out. But it has an additional feature to allow you to manage user accounts and look at their statistics. This is where the preparation of creating the purchase table comes into full effect. By extracting data from the table based on individual users, full records of their shopping cart history can be viewed. You can see the details page for the user we just created, S1, where an image shows how many items they bought, removed, and is currently in the cart. So we purchased 4 items, we have 1 in cart, and then by clicking on the columns, you can see more details of the price ranges in $50 increments. If I scroll down to the bottom table, which shows all the details, time added, time removed, user activity, in the middle column, the user activity is a blank column. It's neither buy nor removed, and this means that it's currently in the cart and it's in transit. Going back a page, we can see this table shows a list of users who are registered to the Bookstore web application, and we can also see an additional field which contains a button for every user named ban. This is so the admin under certain circumstances can ban certain users from actually logging into the system. So if I ban S1 that we've created, and then I log out of the admin and try to sign in with the S1 account, we can see that a message shows the user is banned, you cannot access the system. So we go back to the admin quickly, go manage users, and unclick ban. And when we actually log out again, and then try to log back in, we can log in at S1. So it's working as expected. And this button works using Ajax again. If you remember in the seller function, under my items, it's basically the same operation as pause. It sends an Ajax request, which eventually performs a Hibernate query, changing the state of the banned boolean for the user the admin selects. Thanks for watching, guys. Hope you enjoyed this walkthrough for our version of an online bookstore. I certainly enjoyed it. Give a thumbs up if you liked it and put your comments below. Bye.